Hi students, welcome back. Today we will study about moment of force and equilibrium. In this video, you will study in detail about translational and rotational motion, then what is torque or moment of force, what is couple forces, then at the last you will study about equilibrium. So let's start. When a force acts on a rigid body which is free to move, the body starts moving in a straight line in the direction of force. This is called linear translational motion. Suppose this is a toy car and we apply a force here. Force is being applied. What will be the direction of the toy car? The toy car will move in this direction or in the direction of force in a straight line. When a body is free to move and it moves in the direction of application of force in a straight line, it is known as translational motion or linear motion. Now, second, what is rotational motion? If a body is fixed at a point, the force applied on the body at a suitable point rotates the body about the axis through the fixed point. Then that motion of the body is called rotational motion, and the force produces a turning effect, and that turning effect of force is known as moment of force or torque. So in this example, this door is fixed. This is a body or a door which is fixed at one end and is allowed to move only at the free end, right? And it produces a circular movement. Similarly here, this bolt is allowed to move along this axis. So it takes a circular path of rotation. Similarly, in this example, when force is applied at the turning point, so the body takes a circular way. So these are the example of rotational motion, and the turning effect of force is known as moment of force or torque. Let's see what is moment of force or torque in detail. The turning effect of force applied on a body about an axis is due to moment of force. There are two factors which affect the turning of a body. Let's see this example. What are the two factors? First, force. The amount of force applied. If I apply a small force, the merry-go-round may take a half turn. If I apply a big force, then it may go round twice or thrice. So it depends, the turning effect of the body depends upon the force or magnitude of force, then the distance between the axis and the point of application of force. So it depends upon these two factors. So moment of force or torque is equal to the product of magnitude of force and perpendicular distance of the line of action of force from the axis of rotation. So moment is force into distance. In this example, the body is fixed at this point. The body is fixed at this point and we apply a force at this point. Suppose the body is such a big one and we are applying a force at here. So what will happen? What is the torque here? Torque is what? Force into distance. So force is given 10 Newton into distance is 0.50 meter. So it comes as 5 Newton meter. This is the moment or torque or what? Moment of force. So what is the unit of moment of force, or what is the unit of torque, or what is the unit of moment? It is unit of force into unit of distance. So unit of force is Newton and distance is meter. So unit of moment of force is Newton meter. The CGS unit is force. Moment of force is dyne into centimeter. In MKS unit, it is kgf into meter and gf into centimeter in CGS unit, where the force is measured in gravitational unit. Force is measured in gravitational unit is, what is force? Let me write it here. Force is equal to m mass into acceleration. When force is measured in gravitational unit, what we can write? F is equal to m, and instead of a we will write acceleration due to gravity, right? So what will happen when force is measured in gravitational unit? Force is given in the unit of kg, mass is the kg, and g is measured in f, kgf, right? So similarly, so what will be the moment unit? Moment is what we studied, force into distance. Force is kgf, and then this one distance is measured in meter, so kgf meter. Similarly, in CGS unit it will be gf centimeter when force is measured in gravitational unit. We already know that 1 Newton is 10 to the power 5 dyne, then and 1 meter is 100 centimeter. So multiplying this total, it comes to 10 to the power 7 dyne centimeter. 1 kgf into meter is how much? 9.8 Newton into meter. Similarly, 1 gf is how many dyne? 980 dyne into centimeter. So these three are just for remembering for solving problems. Now let's see what are the examples of turning effect of force. In this example, a spanner has a long handle to produce a large turning moment by a small force applying normally at the end of its handle. Now let me write it here. Suppose we already know that moment or torque is equal to force into distance. Distance between the point of application of force and the fixed end. So I have written it here. Suppose here I say that I have already got moment is Newton meter, 4 Newton meter. Force is 1 Newton. Then what will be? D is value or distance between them. It should be 4 meter, right? So another if the same 4 Newton meter stays, I can write it as 2 Newton into 2 meter, or it can be 4 Newton meter can also be written as 4 Newton force into 1 meter distance. So as we can see from these three cases, if the force is applied less force, then what we have to do? We have to increase the distance between the two, application of force and the fixed point. So here what we did, in order to produce a greater turning effect or greater moment or greater torque, we increase the distance of application, so to produce a greater torque. Similarly here, as you can see, this is a bicycle pedal. What we see that the distance between the two wheels are made large so as to provide a large torque. Similarly here, we can see that the steering wheel, the force is applied tangentially to the rim to produce a turning effect. Then if suppose, let's see, this is a door, and what happened? We apply, this is a fixed end and this is how it rotates, motion as I have shown in this figure. Suppose I apply a force here first. Let's see, I have applied a force at this point. What will happen? You will try applying a big large force and then it might open. But when we apply force at this handle point, then what happens when we apply force here? A little force is applied and the door opens. Why? Because the moment arm or the distance between the two is large. Here the distance is very less, so a greater force is needed. Whereas here, since the moment arm or the distance is large, so less force is applied. Similarly here what we did? We have kept the distance large so that when force is applied, it will produce a greater moment or a greater torque. Moment of force will be greater. Now what is clockwise and anti-clockwise moment? Now as you can see, if the rotation is in this direction or like this or in the clock direction, then it is clockwise moment. And if the direction is opposite or an anti-clockwise moment, then it is known as anti-clockwise moment. Then if the direction is clockwise, then it is a negative torque or negative moment. And if it is anti-clockwise, then it is a positive torque or positive moment. Now, what does the principle of moment states? Principle of moment states that when an object is in equilibrium, equilibrium means in balanced position, it should be always sum of anti-clockwise moments is equal to the sum of clockwise moments. Let's see this example. Here, anti-clockwise moment is force into D1, anti-clockwise moment. What will be the clockwise moment here? F2 into D2. So what principle, according to principle of moments, F1 D1 is equal to F2 D2. In this case, let's apply the principle of moments to this case. So the body is fixed at this point. So anti-clockwise moment is F1 into D1. F1 into D1. What will be the clockwise moment? Sum of clockwise moments. F2 D2 plus F3 D3. So F1 D1 is equal to this all. So sum of anti-clockwise moment is always equal to sum of clockwise moment in case of principle of moments. What is a couple? A couple is a two equal and opposite parallel forces not acting along the same line to produce a turning effect. It is a special case of moment. As you can see here, this two forces are equal and opposite, and if this force moves like this and this force is moving like this, so it is producing a turning effect. So it is a special case of moment, and these two are equal and opposite parallel forces. A single force applied to a body fixed at an axis doesn't cause a turning in a body, as we have already seen many examples. Turning is always produced by a pair of forces. In the examples we have seen before, turning is due to two forces. One externally, which we have applied, and second is the reaction force at the fixed end. The reaction force is equal and opposite to the applied force. Remember Newton's third law? What does it state? To every action, there is an equal and opposite reaction. We had already seen this diagram previously, turning effect example. But we didn't see that there are two forces which always act on, which produce a turning effect. Suppose this is moving here. So this hand, the force is applied this side. Similarly here, what happens in bicycle? If we apply one force here, another force is applied here. And these forces are equal and opposite. So for turning effect, a pair of forces always act, and the pair of forces which act and which are equal and opposite and parallel to each other and doesn't apply in the same line is a couple. Similarly here, forces are being applied. Here we apply of one force and another force is exerted here, reaction force. So what is a moment of couple? Moment of couple is equal to the product of either force, one of the force, and the perpendicular distance between the two forces. Here what will be then? It will be the moment of forces, one of the forces F, or you can take this one or this one. One of the forces into the distance, that is AB, or I have written it as D. Let's see this one. Moment of force at the point A. Let's see, moment of force at the point A will be how much? Force F into distance from the axis to this. It is OA, right? We have written OA. And it is turning anti-clockwise. Similarly, force at the point, moment of force at point B will be F into OB, and that is also anti-clockwise. So total moment of force of couple is F into OA plus F into OB. That becomes F into AB, that is F into D, anti-clockwise. So when we have to take the turning effect or torque of a couple, then remember just one force, either one force into distance between the two forces. That is moment of couple. Now, what is equilibrium of bodies? As the name suggests, equilibrium means equal, right? When a number of forces acting on a body produces no change in its state of rest or motion, the body is said to be in equilibrium. When the body is in equilibrium, sum of clockwise moment is equal to sum of anticlockwise moment. As you can see in this example, what happens? Person A is moment. Let's calculate. Force into perpendicular distance from fulcrum or the mid axis. So 400 into 2, that is 800 Newton meter. Similarly, person B's moment is again 800 Newton meter. So person A's moment is equal to B's moment. So clockwise moment is equal to anti-clockwise moment. So the seesaw is in equilibrium. So if number of forces also act on this body, then also it remains in a stable or balanced position. Equilibrium of bodies mean in a balanced position. There are two types of equilibrium. One is static equilibrium, another one is dynamic equilibrium. First, static equilibrium, when a body remains in state of rest under the influence of several forces, the body is said to be static equilibrium. Let's see this example first. This example is a book example. What happened? A book is placed on the table. So, a book exerts a weight of the book is exerted on the table, which is given as Fg. And then what happens? An equal and opposite reaction force is exerted by the table on the book, that is Fn, normal reaction force. So the book remains in stable position because plus F minus F. What will be the equation? Plus F minus F, and if they are the same quantity, it cancels out. So the book remains in a stable position. Similarly here, what happens? A person standing on the ground exerts a weight of W. The person's weight is W. And then that is a force exerted by the person on the ground. And then from the ground, an equal and opposite reaction force is exerted on the person. So this also cancel out. Weight cancel out with the reaction force. And so the person stands stable on the ground. But in case of a moon, where scientists go, you can see that the scientists cannot walk properly on the ground. They feel unbalanced. Why? Because the reaction force which should be exerted by the ground is very less, or the gravity or the force which is exerted by the ground of the moon on the person is very less, so it doesn't cancel out. So the person will float in the surface of the moon. What is dynamic equilibrium? When a body remains in the state of motion under the influence of several forces, the body is said to be in dynamic equilibrium, as in the case of a solar system. Even the planets and the sun are under several influence of forces. They remain in the state of motion all the time. Now, from these all examples which we have studied, another example for dynamic equilibrium is a body moving in suppose a body is moving with a constant height, like an aeroplane which moves at a constant height with upward lift on it, balances the weight downwards. So from all these examples that we saw, we knew that there are two conditions which must be satisfied for the body to be in equilibrium. First, the resultant of all forces acting on the body should be equal to 0. How can we know this? See, plus F, suppose a bowl is here. Suppose this is a table and a bowl is put here. Now suppose you have applied here 3 Newton force, right? Here is a person who is applying 3 Newton force with his hand to the bowl, and here are two babies which are applying 2 Newton force this side and another 1 Newton force. So what will be the total force acting on this cup? Let's see. 3 Newton from this side and from the other side 2 Newton plus 1 Newton. That is again 3 Newton. So what will be the resultant force? 3 Newton minus 3 Newton, that becomes 0. So the resultant of all the forces acting on the body should be equal to 0. Then second condition, the algebraic sum of moments. Whenever moments is involved means there is a turning effect. Turning effect is produced. Moment is torque or turning effect. So algebraic sum of moments of all forces or torques acting on a body about a point of rotation should be equal to 0. As you can see here. Here what will be the weight is 100 and the distance suppose here is d. This much distance is d. Here the distance is again d. Now let's calculate the moment. Moment, what we have studied, anti-clockwise moment is equal to clockwise moment. So this one is anti-clockwise. So what will be the weight? Suppose the weight is 50 plus 50, 100 Newton into d, right? The distance. And what will be the moment here? Again 100 into d. So what will happen? Clockwise moment is equal to anti-clockwise moment, right? So when algebraic sum is equal to 0, so if I take it to this side, what will happen? 100 Newton into d minus 100 Newton into d is equal to 0. So algebraic sum of the moments of force is 0. When these two conditions are achieved, then a body is said to be in equilibrium. Thank you for watching this video. If you have any questions, please leave them in the comment section. And if you have understood the concept, please like my video and subscribe to my channel for more updates.